So when we get done, or we get to the end, and we have some work time, whatever, somebody might remind me, hey, you're still recording. Up in the menu bar, I've got an option to stop recording them. All right. And one of the things with the smartboard thing, what'll happen is if we're writing, and I may have to go back and forth to close it, and I showed some of you with the markers and the screen capture. So if I'm writing over here, that's one of the reasons I moved this over here today. So if I write up here, and nothing happens, then we have a problem. Maybe not. Maybe it's still. Sort of. Came out perfectly. Sort of wrote. Kind of. Yeah. Okay, that's a little better. Okay. So anyway, it's capturing that in the background, and so you should be able to see most of what's going on. All right. Although as it's recording, it's just doing a screen capture, so I would have to remember. I thought as soon as I started writing on that would pop to the front, but it doesn't. So again, you can help remind me. I'll have to make sure that's on the front because it's not capturing it for the video if it's not on front. Okay. So on the homework questions, I know we'll probably take a look at number 49. Any others that you want to ask about? Number 48. Okay. And 47 is somewhat similar to that. Any before that? $18. Okay, the one with the trig function there. Okay, so the first thing we may do here is go ahead and graph sine. Let's graph sine of 2 pi x, and as I look through the questions on 18, the only interval that they seem to talk about is the interval from 0 to 3. So I would say I'll go into my window here and set my window from 0 to 3. Maybe set my scale to 1. Oops. What about my y min and max? 1 and -1, really. So I could, if I want to see a little bit more than just that, a lot of times what I'll do is -1.5 for that one, and 1.5, and away we go. So that's the graph I'm looking at. So be able to set an appropriate window for yourself. The period of this ends up being what? 1. And that's because if you have a 2 pi on the inside, that compresses it by that factor. So where it had a period of 2 pi before, it would be 2 pi divided by 2 pi now, which is 1. Okay, so it's got a period of 1. So I know that this point right here would have to be 1/2. And this peak would have to be at 1/4, right? See, those are the things that I know about the sine curve, the symmetry and how it works, that's going to help me answer those questions. So when it asks me where are the maximums, local max, well, there'd be one, and this is how I would write this. I would want to say at x equals, this is going to be interesting, help me. I'd want to write this for number 18. I'd want to write this at x equals 1/4. I don't know, what part was that asked for the local maxes? F. Was that F? Okay. So there'd be one at 1/4. There'd be another one. What would this one be right here? 1 and 1/4. Now, if you didn't know that, you could trace, right? So you could trace and find those. 1 and, oops. Jesus. Maybe you have to give this to Jason. Okay, so x equals 1/4, x equals 1 1/4, you know, so forth, and so on. Okay, somebody who said ask for 18, which part of that? We got the domain would be negative, all the reals, the range would be negative 1 to 1, that would not have changed. Is f even? No, it's odd. It is periodic, the period is 1. Where in the interval 0 to 3 is f increasing? So if we go back to the picture, it's increasing from 0 to 1/4. Jacob, you just want to put that away, probably be the best thing. Thank you. From 3/4 to what? 1 1/4, right? It's in. This would be 1 3/4. No. Yeah, 1 3/4 to 2 1/4. It's increasing, and finally from 2 3/4 to 3, it's increasing, right? I mean, when we want to know, when we say where is it increasing, we mean what's the x interval, right? From what to what along the x-axis, from what period there. So just use your oops, I just moved. So it looks something like this, from 0 to 1/4. That's the interval where it's increasing. There's no need to include the endpoints, right? From 1, what was the next one? 1 3/4 to 1 1/4. It's increasing. On and on and on. Okay? Yes? 8 says, are there any inflection points? And if so, where are they located? Now, we were looking in here this morning. A few people came in and were working here. And in the solutions manual, I'm pretty sure they're wrong because they asked for the inflection points. And the inflection points are where the concavity changes. Well, it so happens, because of the symmetry of the sine graph, that this is cosine down until here. And then it switches to, concave down until here, and then it's concave up until here. And then those are the inflection points. So right at the x-axis is where they'd be because of that symmetry. So that would be at, where's it cross here? 1/2, at 1, at 1 1/2, at 2, at 2 1/2. Now, we wouldn't include 3 because the question said in the interval, I think, it said in the interval 0 to 3, but it didn't include the endpoints. So we wouldn't include those as inflection points, okay? So those are the inflection points on the sine curve. They happen right there at the x-axis. Okay, and this is the kind of stuff when on the board here, we're talking about the quiz. Use your calculator to graph and trace, find roots, max, min, inflection points, you know, those kind of terms that we've been talking about, and find where they are. Okay? Now, when you trace, I don't think it did tell you inflection points, does it? If you trace along here, it'll tell you a maximum. Tells you a 0, but it didn't tell you it's an inflection point. Now, I think there might be a menu option. 5. Right there. Inflection. And what's it ask for? Lower bound. So I could move. You can move with the arrow keys too. It's asking. I think. There's one right there. So it'll ask you for a lower bound and upper bound, and you can move along and point with the pointer and click or whatever. So that's another handy thing that comes in. Now later on, you know, we will, even if it's a calculator problem, if we're looking for maxes, mins, inflection points, we won't be able to just go to the graph here. Now, if it's a calculator problem, you could certainly use that as a check to see if you found it right. But there's a whole series of calculus steps to go through to find. That of course, the calculator's doing in the background. And when we learn how to do those steps, we're going to have to show that work. But for right now, we can do that. We can use it. Okay. So 40, let's talk about 47, 48, 49. 47 talks about this. Okay, 47 talks about a line y = 2 as a horizontal asymptote. Now, one thing about a horizontal asymptote, I want to make sure everybody see if I can Erasing a line that was never there. All right, so I've got the line y equals 2. Now, some people mistakenly think that an asymptote, you can't cross an asymptote. That's true of a vertical asymptote. Because a vertical asymptote is where a function is undefined. But a horizontal asymptote is what the function is approaching in algebra T called an end behavior, right? Out at its ends, at infinity and negative infinity. So it's possible to have a graph that kind of goes like this, and then like this, and then levels off towards that line, and that would be a horizontal asymptote. Okay, so it is possible to cross a horizontal asymptote. Okay, but not a vertical. Okay, because vertical there is no output there, it's where the function's undefined. All right, so suppose we have this horizontal asymptote y equals 2. Explain why the line y equals 5 is a horizontal asymptote of g of x equals f of x plus 3. Well, what happens there? If I take that graph there and shift it up 3, the asymptote goes with it. So it's going to be at y equals 5. On B, that's going to shift where? Left 1. If I shift that graph left 1, what's a horizontal asymptote? Same. Still y equals 2. C. What happens if I do those 3 things to that graph? Well, what happens to that graph on C? It goes left 4. Let's go into order that it would probably happen. It's kind of like order of operations. Start inside the parentheses. It would shift left 4. What would that do to the asymptote? Nothing. It would do what? What's a 3 do? Stretch. Now let's talk about a vertical stretch. Now when we talk about a vertical stretch, I usually use this hand motion like this. Okay? But what I really mean is that all of the y values will be 3 times as much. Now on my graph, all of the y values are positive. Right? So will this point down here actually go down here like this? Will it actually pull down by a factor of 3? No. So when I do this, I'm thinking of a graph that is above and below the y-axis. Because if you got a y value of -2 and you multiply it by 3, it's now -6. So it's pulled down by a factor of 3. But if all the y values are positive and you multiply by 3, they'll all still be positive, but they'll be 3 times as much. Right? So these y values here that are approaching the y value 2, what will happen when you now multiply them by 3? They're going to be approaching 6. Right? So all these y values will be 3 times what they were. Now if they were negative, yeah, they would go down here farther. But any of the positive ones get 3 times as big. So these values that are getting closer and closer to 2 are now going to be getting closer and closer to 6. Then you shift it up 1. So it's now y equals 7. So the 4 didn't have anything to do with it. But the multiplying by 3 and the adding 1 did. And so the horizontal asymptote y equals 7. Okay, 48. Now we've got another graph here. And we've got a vertical asymptote at -3. Okay? All right. So on A, if we shift it up 3, what happens? Let's put a... Oh. Let's put a graph in here. Vertical asymptote at 3. So we shift that up, nothing happens. It's still asymptote at -3. In B, if we shift it left 1, the asymptote's now at x equals -4. And on the last one, same scenario. If we move it left 4, it's going to be at -7. We stretch it by a 3 factor. Doesn't affect it, right? So it's still at negative, what did we say, -7. And then if we shift it up 1, that doesn't affect the vertical asymptote either. So we got x equals -7. All right, let's take a look at 49. Okay, let's go to a new page. All right, number 49. We've got f of x equals this. And what's the other one called? G of x. Okay, now when you look at number 49, I mean, what do you think of right away? Factor, right? I mean, probably that jumps right out at you right here that we can factor this. We got x minus 3. We got x plus 3, x minus 3. We can cancel those. And so we get f of x equals this. And I mentioned this the other day, I think, in one of the class anyway, where in algebra class we tend to think, well, this is equal to this, right? Because, you know, that's how we do it. We start with this, we work it all out, equals, 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 just like I did here. You know, I put these equal signs in here, and so that's saying, okay, they're equal. Well, they're really not equal. They're not equal. What's the difference between this and this? Domain. I can put a 3 into G. G of 3 is 1/6. F of 3 is undefined. 0 over 0, which is undefined. So other than that, they're exactly the same. But right here, when I canceled an x minus 3, I lost where the 3 made this be a 0 over 0. Okay? So if I put a 3 into this, I get undefined. If I put a 3 into this, I get 1/6. I changed the problem just a little tiny bit. Okay? But I did change it. All right? So now let's take a look at the calculator. I know they're going to ask some questions here. It says, show that f of x is equal to g of x for all x such that x does not equal either 3 or negative 3. Well, that's what that work showed right there. These are equal as long as x doesn't equal 3 or negative 3. Now, actually, if it equals negative 3, it's okay. But they just took it out because that's not in the domain. Well, then B says, find the domain and range of f. Well, the domain is all reals but 3 and negative 3, right? We can't put a 3 or a negative 3 into this. All reals but 3 and negative 3. The domain of this is all reals but negative 3. Right? So this one can have everything but 3 or negative 3. This one can have everything but negative 3. When we just said that. It's okay for this one to have 3 in its domain. Okay, find the domain and range of G. Well, we just did the domain of each. Now let's do the range. And here's where the calculator comes in real handy. So let's go to our calculator. Go down here to this little blue thing where it says show entry line. And up comes f of 2. If you want to get rid of f of 1, then you can just up arrow. If you up arrow, there's F1, and then you can delete. Okay, and you can delete F1 so you don't have it in there. Get clear or whatever. I don't know if clear will do it, but just delete. Okay, so now I want to type in. Now let's do that in order. So let's go the quantity x. So I hit my left parenthesis. X squared. Oh, whoops. It's x minus 3 on top, right, parenthesis, divide, and then, I should have used that fraction template, that would have been better. X squared minus 9. Okay, now, I still have my window from before. Let's change our window. Now, once again, the calculator is very little use to you if you don't have a sense already of what these graphs look like. What does this graph look like right here? It's one of the graphs we talked about that we should kind of start to learn. So 1 over x graphs, that hyperbola in the first and third quadrants, but it shifted left 3, right? So that makes me think, well, I want to look at least, I'll say negative 7 for my x min, and I don't know, 4 maybe for my x max. It's going to get really big pretty fast. So maybe I'll go negative 10 to 10 for my y's. Okay, there we go. And then I get a pretty good, now it doesn't show the asymptotes, okay, but there's our picture. Now, watch what happens if you trace. Okay, obviously, hang on here, let's back up a sec. We know that this graph, we cannot put in a 3 or a negative 3. Well, look what happens at negative 3. Clearly, undefined, vertical asymptote. What happens at 3? There's no vertical asymptote, is there? Now, this is something that won't be a big deal on the quiz, but it will be a big deal later on. If we put a negative 3 into this one, we get negative 6 over 0. That's a vertical asymptote. Anytime you have a number other than 0 divided by 0, that's a vertical asymptote. 1 over 0, 6 over 0, 7 over 0, negative 6 over 0, vertical asymptote. When you get 0 over 0, which is what happens at 3, that's typically a hole in the graph. So if we trace right now, and unfortunately it doesn't show us, it'd be nice if it showed a great big hole there, but if we keep tracing, and if I type in a 3 and hit enter, it does put a little vertical line. That's nice. Our old calculators didn't do that. It puts something in there, but it says 3 and then it says undefined. So there's a hole right there. Okay. Now, what's going to happen if we graph this?
It'd be the
same thing, except there won't be a hole there. When we trace to 3, we'll get 1/6, 0.1666 repeating or whatever that decimal is at 1/6. Okay? So, but otherwise they'll look exactly alike. And if you graph them both so they're on top of each other, they're probably different colors. So if we go 1, and we go x plus 3, okay, now you got the green one, okay, on top of that one, okay, and so then we can up arrow and go to the different. And there's the red one. How do we well, this is interesting.
Oh, great.
Oh. I'm curious how you go back and forth between
Just like the up.
Arrowing up again.
up arrow. All right, so oops, let's close that. Oh, okay, yeah, that makes sense. That shows both of them that we have there. And if we hit the up arrow, oh,
Or like
When you're in there, and you can hit the eyes, and that'll take one off the screen.
oh, here we go. Here's how I close it. There we go. Okay, when I'm tracing, you can hit the up arrow. Okay, I thought for sure. Okay, I guess not. Okay, so let's go into trace. And so if we trace to 3, okay, there's our 1/6. If we hit the up arrow, we get it goes back and forth between the red and the green. Oops, I lost my 3. Oh, yeah, I have to hit the 3 each time. Yeah, I have to hit the 3 each time because it wasn't right on that point when I went to the next one. Okay, so you can trace and learn these various things. So now, back to the range question. So now, once you have the graph, it's pretty easy to see the range. Okay, it's all the y values. Well, for the first one, for the red one, it's all the y values are negative infinity up to 0, but it doesn't hit 0, right? So it doesn't have a y value 0, so you wouldn't count that. Then it hits these y values from 0 up to 1/6, but there's a hole there. So if you look in the back, it'll say 0 to 1/6, and then it'll say from 1/6 to infinity, because it doesn't include 1/6. On the other one, it's negative infinity to 0, 0 to infinity. It's everything but 0. Okay, so you could say, well, it's all reals but 0 and 1/6 for G. And you could say it's all reals but 0 for F. Okay? Or other way around. Other way around. Yeah, other way around. F is all reals but 0 and 1/6, and G is all reals but 0. Okay, so that's domain and range. How are they related? They're the same except for that hole in the graph. Does it have a horizontal asymptote? Yes, it does at y equals 0. Does it have a vertical asymptote? Yes, at x equals -3. Okay? All right. Anything else? What about a 19C? If I ask you that question tomorrow, you'd be good to go? I don't know how your other math classes have been, but on the quiz there are not answers to the odd problems in the back. I don't know if Mrs. Payne did that or not, but unfortunately. So what would we do? What would we do? Use the properties of sine and cosine to show that tangent is an even function or an odd function. Tangent x is sine x over cosine x. Now one habit you might want to get into, and you'll notice I do all the time, is when I write sine and cosine, I may say sine and cosine, but I know when I taught advanced math, I didn't put parentheses around the x. But everything is about functions here, and the arguments and the inputs, and the calculator needs the parentheses, and so it's a pretty good habit to get into. Same with natural log. I know when I was teaching trig, we were doing trig identities, it got to be a pain to put parentheses all the time, so I usually did. So, but for this class, it's a little more important in general. If you write sine x plus 2, what's that mean? Oops, see, I'm such a habit, I can't even write stuff. But if I write sine x plus 2, what's that mean? Is that a vertical shift? Or is that a shift to the left?
You don't know.
You don't know. You really don't know. Okay, you could guess that it's a vertical. The person who wrote it meant vertical shift, but we don't know. Depends where the parentheses are. Okay, so here's how you could show this. What do we know? It said use the property of sine and cosine. In other words, we know sine and cosine are sine's an odd function, cosine's an even function. So that means if you put opposites in, we're trying to see if tangent is an odd or even function. Well, one of the things we said was opposites in, opposites out, or opposites in, same out. What that means is if a function's even, you should get the same thing out if you put in x and negative x. If a function's odd, you should get opposites out if you put opposites in. So what we should do is, here's what tangent is with x in. Let's put negative x in and see what we get. This would be a really good way to answer this question. So let's put a negative x in to the tangent function. And that would equal this. Well, what's sine of negative x, since it's an odd function? Negative sine x. Now what's cosine negative x, since it's an even function? Positive cosine x, or regular cosine x. Negative sine x over cosine x is negative tangent x. So tangent of negative x is equal to negative tangent x, which means tangent is what? An odd function. Opposites in, opposites out. That would be the best way to answer 19C. Okay? All right. So, for the quiz tomorrow, a lot of this stuff is carried over even in here to section 1.3 with the even odd questions, the transformation questions. There's that thing with piecewise and the circle, right? So, nobody asked about that one, and nobody seemed to have any problem with that one before. So, but if you did and still haven't come to ask me about it, you probably should. But you're going to have to do something like that, be in the domain range questions. What we just did with a calculator with tracing and maxes and mins and set your window and things like that. Okay? Just reading graphs. It's a lot about graphs. Whether it's from your calculator or not, I might just give you a graph. And, and ask you questions about it too. Okay? All right. Well,
let's